Hallo, herzlich willkommen zu unserem Roundtable zum Thema 3D AOI. In dem Programm war es nicht ganz eindeutig geklärt, also dieser Roundtable wird auf Englisch stattfinden. Deswegen werde ich jetzt auch gleich ins Englische switchen. Okay, welcome to our panel discussion about 3D AOI. My name is Markus Strehlitz and I will be the moderator of this panel. And the automated optical inspection is the favorite method for the quality control of PCBs. And over the last years there has been a trend towards 3D, which means from 2D AOI systems to 3D AOI systems. And that's our topic for today. We're going to discuss the optimal, what it takes for a system to be the optimal 3D AOI system. And I'm looking forward to have an answer after an hour for that question. We will see. And and we have the perfect experts here for this topic. And I would like to introduce you from the left to the right. It's John Bashe, General Manager with Parmi America. And then it's Carsten Salewski, CEO, Viscom. And Jaroslav Neuhauser, Deputy General Manager with Saki. And as you can see, there's still one missing. We're still waiting for Harald Eppinger, Co-Young Europe. But I think he will join us in a few minutes. Okay, so then let's start. I would like to start not with the system itself, but more with a let's say general question about the challenges that the companies face in the processes of the inspection of their PCBs, and what are the requirements that your customers have on an AOI system. I would like to start with that. So who would like to answer first that question? What are the challenges?
I can. Challenges. I mean, it's maybe differentiated by region, by markets, and so on. So we have a lot of high volume customers with automotive high quality boards. That's a certain challenge. But we also have smaller mom and pop shops, as John would call them probably in the US, who have low volume and high mix. Yeah. So the challenge is definitely how do you accommodate both in programming time, inspection quality, and what you need. I don't know.
What's your point of view?
Another thing I think that's a challenge in our industry is, again, the wide range of types of products that are being manufactured in terms of different types of board materials, surface finishes, component materials, component finishes, component sizes. There's such a wide range of applications. Again, we have high volume customers in consumer products, cell phones, laptops, and you have high volume in automotive. It's a different market, of course. And then you have small to medium volume in military, aerospace sectors especially, and each has its own special requirements. So there's no system, there's no one system that fits all perfectly. Okay. We all know that.
Yeah.
Right. Everybody makes a good machine, but no machine is perfect. No machine fits every customer's environment. So that's the challenge, I think.
Okay. Well, Harald is not here. He would probably disagree.
From my point of view, I think the major challenge is to find the right balance for the customers between the flexibility and ease of use. Because, the flexibility comes with responsibility. Yeah. And, these days, of course, there's a lot of tools how to optimize the programs, how to make the programs quick, etc. But we have to keep in mind the flexibility is very important to be kept. And this can differentiate, I think, our technologies from each other, whether it fits to the customer needs or not, and whether he has the let's say, the crew or a team who is able to handle, or whether the system is really easy to handle by anyone actually in the company. So, so the balance between the flexibility and ease of use, in my opinion.
In the introduction, I said that there's a trend from 2D to 3D technology. how common are 3D AOI systems now? Is it a totally replacement of the 2D technologies, or how common are they? What's the adoption of 3D?
I mean, the 3D inspection is definitely the trend, and at least in Europe, we see 95% of the projects we have is really towards the 3D.
95.
I would say.
Okay.
There's always a field of application where the 2D inspection is sufficient. It can be post-selective wave soldering inspection or some kind of back-end inspection, so some measurement of some mechanical performances, etc. But the trend in SMT is definitely the 3D inspection systems with the combination of the 2D inspection techniques. Yeah. That's very important. I think the 3D system itself will not solve all of the challenges.
Yeah.
The 2D is really essential part of the inspection system itself.
Okay.
Yeah, I totally agree. So today's market is almost pure 3D AOI systems. Okay. But I'm glad you're mentioning that. There's always an application for 2D or 2.5D. I don't like the term, but that's pretty much angular cameras, where you have certain features that you can better classify with a 2D approach. If it's OCR, for example, I mean, OCR in 3D is a challenge. But going back maybe 30 years with the beginning of AOI, it was maybe one camera, just a 2D approach. And only 5 years ago, I think the technology, the computing power was good enough to really process the data. For example, our AOI systems, the cameras, we have over 120 megapixels of data. So that's 9 cameras taking a shot, and then we have the fringe projection on top. So that's what you need for 3D. And this is done in a few hundred milliseconds to get a 3D measurement of a field of 50 by 50 millimeters. So that wasn't possible, 5 years or longer ago. And we all benefit from the advancement in computing power and alone to get all that data into the computer. So we have a fiber optic bus system that actually brings all the information into the computer to do the 3D measurement reconstruction.
Okay.
Yes, and I'd have to agree also that the market for 2D systems currently, I think, is very limited, and it's decreasing over time because, as with any new technology, older technologies become phased out. Again, 2D inspection is also important in applications for OCR and some other applications. We need to combine 2D and 3D for maximum flexibility. But the market for 2D systems currently, I think, for companies, well, maybe some very small companies with limited resources, maybe they buy older 2D systems because of the price. But those will quickly be obsoleted, and there'll be a need to upgrade in the future. So.
Okay, cool. So the fourth chair isn't empty anymore. Welcome, Harald Eppinger from Koyang. Great you're here. Yeah, and here's your mic.
Thank you very much.
You didn't miss that much so far, so we.
Hey.
Okay, I would.
Now it's getting funny. Yeah, it's good.
Okay. Good. Now the most important person is here, so then we can really talk about real stuff. Yeah. No, we just talked about the adoption of 3D technology and the comparison to 2D and so on. And but what you said when we talked, when I asked for the challenges and for the requirements that companies have on an AOI system, you said you have to find the balance between the flexibility of the system and then it's still easy to use. So is that one of the biggest challenges that you have when you invest in a new AOI system, or you try to figure out which kind of AOI system you need, that you find that balance?
Yes, that's definitely one of the points. Many customers are having different requirements, and we always approach the customer in a way that we want to be a partner them and listen what are their requirements and wishes. Of course, we have a technology or industrial standards of the inspection, inspection quality or quality of the products in electronic assembly. But there is always something which customers want to get differently, or depending on the region, depending on the culture, depending on the way of use the machines. Small customer, big customer, high flexibility, high volume. So from the manufacturer point of view, to find this balance between the flexibility and simple of use and of course the performance. I mean, performance is clear, it has to be as good as possible. On the other hand, this flexibility is sometimes tricky to find. I mean, the balance is tricky to find.
Okay. So Harald, when you I think when you talk to a customer, you give them a sort of consulting as well. When a customer wants to invest in a new AOI system, yeah, do you want to add something? Okay.
I think it's a quite good point here. We might clarify. When we're talking about the flexibility and the ease of use, we are reflecting very often our AOI history, and it's a quite long history of 20, 30 years. Everything is based on the experience at that time from the programmer, from the guy who applies the guidelines. I think it's the wrong approach to reconsider ease of use. It should be easy automatically, but we are still thinking that an operator should have a certain qualification. When the 3D world is approached in the proper way, we are not talking about how to get the 3D result. It's not longer the programmer who is tuning the system to catch the result. It's much more to discuss and to apply the right tolerance. And I think we have to change the mind. The machine has to measure, and we are applying the tolerances. And the tolerance to apply, you can use Excel table. You should be able to program a machine because it's a number of tolerance. You have 5% tolerance, 3% tolerance, if you can follow the rules which is applied within the company. So I think we have more discussion, what is the tolerance, what should be good tolerance, and we're not talking a conform IPC. It's much smaller, the tolerance we should be applied to be able to do predictive maintenance. Catching the defect, I fully agree, it's a must.
Okay.
It's much more to understand the process variation. And then it's not longer how to get it. It must be in or out. I think this is the most important, the ease of use aspect.
Okay. And is that something that's missing in the companies, or?
It's not. I think everybody is happy when he can say, I'm producing according IPC. But if you take a dense board and you apply the tolerance, you have a big mess on the board because it's not possible to run with 25% off pad because it's just too dense. So we have to see what is the quality in production line, and then suddenly you see you have 2 or 3% or 10 or 12 micron offset, or the solder joint height, everything is in 3D, and you have this tolerance. It's not that you jump like this. That was 20 years ago. Now we have this bandwidth of quality, and we have to make sure that the deviation will be visible. And then you can act to the pick and place machine, to the paste, to the PCB manufacturer in a proper way. I think this is the aspect for the future.
No, I agree with you on one thing. I mean, defect detection, that's a must. But it's not a given in all cases. I think most of the evaluations are still about customer comes with prepared boards and gauges the competition between different suppliers by the 100% defect detection. So that's the first one. So I agree, it's a measurement system, but it's also, as we talked earlier about it, it's a combined approach. There are some aspects that you just can't do in 3D, very close to a large connector or something, and there's limited data. So you have to do some kind of combined approach. And but I agree. So it's all about defect detection and then ease of use. That's the second, I guess.
Okay.
I would like to add to that. In addition to defect detection, the usability of the system is really important, and that comes in several aspects. One is defect detection is great, but if you're getting a lot of false calls on every board that you inspect, the usability of the system is very limited, and it can tend to lead to escapes and other mistakes in the process. But also in terms of software, all the systems today are pretty capable. I mean, the optics are very well developed in terms of technology. The computing power is there, the processor speed is there. That's great. But I think there's a tendency sometimes that the the designers will want to add so much functionality into the system so that every possible thing could be adjusted, tweaked, fine-tuned. The problem then is the programming becomes so complex that it's a discouragement to the customer to work with the machine. And I've seen some cases where machines are put off to the side, they're not in line, they put them in the corner. Say, well, what's going on with the machine? It's like, well, we don't have time to program it, and so it's over there. So there's no value to the customer then.
Okay, so the machines are not used because they are too complicated and they're to use, or?
Well, yeah, if your programming time is far exceeding the changeover time for your products, then you'll never catch up. You'll never be able to keep up with the production schedule, and then the machine's not used.
Okay.
So that can be a problem in contract manufacturing.
Okay. Isn't that a point that the users who are working with the machine that they have a limited knowledge and they are not the experts anymore? Is that something that has changed?
Yeah, exactly. We don't assume that the person working the machine has a master's degree in engineering.
Yeah.
You know, especially with the tight labor market. And I know in the U.S., labor market is extremely tight. Unemployment is maybe 3%. It's hard to get qualified people to run a machine. So the goal is, it's a challenge for everybody, but to make a machine simple enough that a lower level person can actually run it. It's a challenge.
Okay. Yeah.
Different markets, right? I mean, I spent some years in the US, and it's different expectations. I mean, in the early years before 3D, I visited EMS shops and they were pointing towards a camera in the corner. That's our AOI. Okay, so check, we have AOI. That's over. I mean, now it's more about process monitoring, and many companies actually take the time to analyze the data and improve their processes. And AOI systems are, you know, they generate a lot of data. Measurement data, but also image data, which comes maybe, I don't know if that's on the topic today, but goes into AI, artificial intelligence, cloud something projects, which are very exciting. And we are in the very early beginnings of seeing how cloud computing, AI is becoming a big part of what we are doing for many years. And it will be a big decision to see how much do we rely on AI and how much do we go with deterministic approaches. I mean, as you said, a measurement system, that's, you have Z information, height information of the whole board. You can make clear thresholds. That's a deterministic approach. And if there's an error in the field, and that's our customers, high-quality customers, if they have a return from the field, they want to know what happened and why does it not happen again. If you go with AI, you can say, I retrained it and it shouldn't happen again. So that's where we are right now, and we'll see in the next, I think, 3 to 5 years, a complete different approach of many customers regarding artificial intelligence.
Okay, so do you want to add? Yeah.
I like the comment because when you talk about threshold, and sorry for this, you're still in the other world. You're not in the world of tolerance. The threshold defines typically something in between. So we have to learn ourselves to discuss in percentage, in a tolerance, which written down in a book of rules. The second part is when you look around here in the industry, and that in our industry, everybody's talking about AI and everybody's talking about to analyze data. We applied about 4 years ago our department R&D for AI, and they told us we don't touch the data yet. We first utilize the AI engines to make the measurement more solid, more precise, and put more efforts in clean data to avoid the data noise on analysis. Without this cleaning process, you will be not able to communicate clearly with pick-and-place machines or start the KPO, the process optimization during the printing, the dynamic process. Because if you have noise, you can just assume what to do, if it's precise. So I think it's a trend in the moment. There's a better understanding. The market is stepping away of thinking in programmer has to do, the QC has to define, and somebody has just to apply. I agree, some of the 2D aspects. But the problem is less 2D. The problem is really what can you get out from the board. And I like the idea there is a limitation on height. What is the limitation? Everybody's talking about shadowing. And we try to help the customer on his board, but the board is not the limit for the machine. So it's much more, and one reason why we developed the test board, not the demo board, which has high components, 105 very close, in between the capacitors, so it should be like this. Not perfect, because there are physical limits, but how much you can go to the edge will secure the process, how you can implement the machine clearly in the production site.
Okay. So originally I just wanted to talk about the AI topic a little bit later, but now we are right in the middle of it. So what's your point on AI?
Of course, this is the approach which our R&D is working on, and we see a couple of application fields in there. Of course, as Harald mentioned, the cleaning up the data, it's one of the major direction. On the other hand, there can be also many more application fields as a let's say advisory function to the line people who are operating the machine. They might be helping to speed up the programming. So I think there are many directions. Of course, now as AI, there's still, we believe that that AI is not in a stage that it can be used for automated inspection or to be used as an engine for the classification of the boards. However, to have the higher level analysis of the data, there's definitely direction we are going throughout the line. That's very important, I think, to get as many point of views, as many eyes in the line as we have. As we are having SPI, AOI, AXI, then it's coming in very interesting analysis, starting from how the volume of the paste is influencing the head and pillow defect detected by the X-ray. And these kind of correlation analysis are the ones which I think are coming soon to be very interesting for our customers, and this data then can be used for optimizing the process backwards, but not a single machine data, but the total lineup data. So it means combined data from the multiple processes. Okay. That's, I think, the way of the success.
There was a point where you didn't agree.
We are coming back to the point that the machine doesn't deliver what you need to analyze. Yeah. So that was, I think, a very important thing. You have to rely. If you don't rely on the machine result, even in critical cases, you should not apply AI engine.
So the data quality is
the raw data quality, what you get from a board, and it's not just one piece of the board, it's the full coverage from left to right, bottom down. Every single component has to be traced 100% with everything you can get out. Then you have a clear picture, and then you can analyze.
Sorry to stop. In that case, that's probably not necessary to use AI then, because the data will be clear and there will be no noise, and that's much easier part even for statistical methods.
The AI engine should be used to analyze the root causes.
To get a good data quality from you,
the data quality is given, and the AI engine should help the operator to see the abnormal things. We are talking about microns. I'm too old to see difference in microns, even with new glasses. But we are talking about the microns, which are influencing and driving a process up or down. And this is exactly what the AI engine has to detect and to advise. And then we have to come to the process guidance.
Let's talk about the human aspect of it. I mean, it's one thing to use AI to improve your measurement data. That's an approach, but first of all, it doesn't have to be 3D data only. AI works very well on images. I mean, if you look what happens right now on your iPhone, pretty much, if you can put in a search term and it finds a cat or a dog or something. That's something. So we actually use AI to assist.
But you need a lot of images to have that.
And we have a lot of images. Yeah. That's the good thing. So if you have a board, you have 3D data, we have image quality from all sides, we have hundreds of gigabytes of data per board, and we can put that up in the cloud and use it. The way we use it right now is already assisting the operator post-reflow at the verification station to see if because the human error is still the biggest risk in the whole line. I think we all agree. If the human says, no, this is okay, although the machine is maybe way more reliable to detect defects, If the human says it's okay, it goes in the field and it's gone. So that's where we use AI to assist the operator and say, by my database and by my experience, this is very likely to be a defect. Let's look at it again. So it's not only the AI at that point, but if you give more information to the operator, like other measurement data in the process, SPI, post-reflow, AOI, you can avoid the human mistake by allowing defects to get into the field.
Okay. So before we go on here with this discussion, I just wanted to open up this discussion. If any one of you has a question here for use the opportunity here to. You have the experts here on stage. So is there any question from you? Okay. Well, we still have time. You can think about it. Yeah, of course. We talked about AIs, and maybe we need a little bit, some more years to really see what the benefit of AI could be in this area. But what are the other, let's say, key factors for a system from your point of view? We talked about flexibility. We talked about easy to use. By the way, easy to use, is that something that's also an argument, or no, it is a point for a good software? I mean, you need a good software to use the system. You need with a good usability. How important is the usability of the software?
Yeah, I'd like to comment on that. Software, as I said earlier, you can have the most sophisticated software package in the world on your machine. It can do everything under any scenario. But if the operator can't use it, it's too complicated, too difficult to navigate the screens, then the machine has a limited value. So it's important that you find a balance between optimal capabilities and optimal, adaptability or adjustability of the system, and balance that with the fact that an operator has to run the system and has to run it all day long, and that needs to be friendly enough to work with it, that they want to be on the machine and not try to avoid the machine because it's too difficult. In terms of other aspects of AOI, I think some very important aspects. So one of them is bandwidth, and by bandwidth I mean how broad of a range of materials and components and surface finishes can the system adapt to. That's critical, because you got the most accurate machine in the world, but if it can't see a surface, it can't measure a surface because of reflections, those types of issues, then that's of a limited value. So bandwidth is important, and flexibility, of course, is important in that area. So
okay. Anyone who wants to add something to software?
We all agree software is important. I mean, we do that for 35 years, and we have our established software platform, the SI software in the market for a long time, many thousand machines running it. And we launched our new software platform, the vVision, with certain things in mind. It's actually less user interaction, and make it very simple for the operator. And we were talking about thresholds earlier. And if you talk about a 3 or 5% tolerance, it's still a threshold. It's either 3 or 5. And there are ways to combine features and so on. But how do you make sure that if an operator changes something in the program, that you still find defects, that you know about? So you can have your cabinet in the back with all the sample boards that are dirty and old and something, put it in the machine again, so I still find it. So we did that on a software platform very early on. We call that integrated verification. So operator confirmed defects are saved as images with measurement data in a database. And when you change something in the program, either move a certain window or range or something, then you can, by clicking on a button, really verify that you still find all your confirmed defects. That's pretty much audit safe. That's what end customers like to see, that you can prove I still find my defects.
Okay, yeah.
I would say getting this defect from the database is very valuable, but it's the worst case scenario that you catch this defect. I still believe that having the deviation under control during the process is much more valuable, because if you find the deviation a little, then you will find the defect. That's a kind of consequences. And I think it comes from the history, absolute. Everybody has his database with defects. Everybody has his so-called golden board in the cabinet. But we have to step away of this, because We have time to market in boards. It's changing overnight. You have a new board. You have new challenges, new pad geometries. You have to retune everything. And I think that's exactly the point what we have to come. We have to step away. You have to, let me say very simple. The goal should be put the board in, put the raw data, the data in, whatever, Gerber files, CAD files, press the button, and the system should know what to do. That's what I would call ease of use. Because we are back on the discussion. If something is not working, then you need the interaction from the programmer. That means the vendor did not do the job. And I include everybody, not everybody, because if this is a problem to be manipulated, there should be experts in R&D to overcome this obstacle by different technology, by different algorithms, by some things. At the end of the day, we should minimize this kind of obstacles.
Yeah.
It could be dust on the board, could be high reflecting components, could be new shadowing, new PCB material, everything. But it should be not covered by the programmer, it should be covered by the guys who delivers the machine.
Okay. So you said it should be, so it's not state of the art at the moment.
It's one by one.
Yeah.
You don't know what kind of material will be used tomorrow. The PCB manufacturers are close to us, but not so close to us that they tell us what they deliver in the future. There's a kind of competitiveness here. But if you're close to the customer, you see the new material, you see flex boards, you see ceramic, you see glass components, all these kind of things. Semicon is moving to PCB, PCB business is moving to semicon. Suddenly you have these totally different businesses linked on one PCB. What should you do? Two systems, one system from semicon and one system from the regular SMT business, and then you have two, nobody will pay it. So this kind of utilizing technology, fundamental technology, bringing into ease of use and easy to handle, easy to bring in the factory, that's the future. It's not done yet, but the homework should be done at the vendor side. And if it's not done, I put it also on our role, we have to do.
Okay.
If it's not covering everything, and there's every day a new obstacle, and there's every day a new challenge in this business.
Oh, yeah. That's a very philosophical approach, yeah.
Actually, I agree with Harald that our duty as a manufacturers is to provide the solutions on the challenges what our customers are having. Therefore, the manual fine-tuning of the parameters and changing the steps, changing the methods, that's something which we need to avoid. I don't know if it is available now or tomorrow. I think all of us can agree that our R&D teams are working on this direction, that generally we should give tools to the customers, or the machine has to function in a way that the fine-tuning or adding additional inspection steps here and there, or moving the window or changing the light source and so on, that's a history, I think. We have to go to the further in the future to simply overcome these kind of, I would say, elementary. I don't mean elementary. I mean that's a very complex thing at the end. We know it all, but to step out of the human-based, even statistical-driven a bit, or statistically added tuning. But we should aim for the fully automated tuning or self-tuning according to the process performance, according to the other processes in the line, by the horizontal communication, for instance, methods.
I don't want to put you on the spot, but I think that's very interesting. I read a little bit about that you differentiate between the self-programming and the self-tuning stage of your machine. I mean, you just said, it was just one button. You said it's two buttons. So if you can elaborate a little bit on how do you actually do this, the automatic self-tuning part?
Of course. I mean, I'm getting a new board. I have to program the machine. Okay, I get the design data. I import the data, and the program is created. That's something. I get a first version of the program. I get the tolerances. I get everything. However, as this is totally new product in my production line, there is some process. So it's important that our tolerances, not all of them, but some of the tolerances needs to fit to the process window, which develops in a time. Therefore, there is in our system there is a functionality of self-tuning, And this is actually adjusting the process window in order to meet the reality which is coming on the line. I think that's pretty natural.
Do you use probably not a golden board, but statistics over the process?
We have statistics over the processes.
Yeah, so, okay. Yeah, because golden board, I mean, you mentioned that earlier, that's something I saw a lot in the States. I mean, if you have a shop who makes 50 boards of one thing, and that's my first one, I want everyone to look like this. I don't see that a lot in Europe.
The first board you get out of the line is the worst one. That's a reality, and we have to face it.
I want to look everything like this. Yeah, that's not a good approach, right?
Yeah.
The golden board, the golden board should be a set of data, not longer a golden board. If you use the terminology, I'm fine. But everything what you apply on the PCB should be rock solid. And I personally like to kill the word tuning. If somebody tunes a process during the real production to somebody, you have theoretically no clue what is the outcome. If it's automatically or done by operator, there is not a big difference. Somebody pressed the wrong button, makes the wrong decision based on the wrong data, and the quality is gone. I think we have to go back to the basics and say, what is the meaning of tuning? Adapting tolerances or adapting the method to come to a result?
Now we are talking about words and words. So if I set tuning, that's more concerning optimization. So based on the history data, to be able to set the right tolerance for certain parameters which are developing in a time. Whichever terminology we will use, this is the reality. Okay, maybe your strategy is, if something goes wrong, I will say it is wrong, and somebody have to fix it, and your system will be solid and nothing will change in. But in my opinion, we have to give immediate answer and immediate solution to the customer. So if he has a process deviation, yes, there is a warning, there is some change in the process, which we have to announce or tell to the process engineering, and that's our duty at the end.
Okay. You just wanted to add something, right?
Yes, I think the notion of a golden board is kind of a historical thing that comes back to the 2D machines from the past, where they were using image comparison. And as you were saying before, we need to forget those concepts, except maybe in the case of text recognition, where we need to have a sample image. But for everything else, it needs to be data-based. Forget about golden boards and reference images, because those are traditionally quite unreliable and create lots of false calls in that area. But again, back to debugging, I mean, the goal for all of us is to minimize the debug or the fine-tuning, whatever you like to call it. Optimize the program for minimum false calls and zero escapes, right? Okay. We all want to reduce that time to an absolute minimum, because that can be a big burden in production environment. The debugging or fine-tuning aspect is very, very labor-intensive and requires a lot of human involvement. And again, the goal is to minimize the amount of human intervention to minimize mistakes.
Yeah, okay. I would like to, talk about another hype topic, which is smart manufacturing, and how does an AOI system has to fit into such an smart manufacturing approach. I mean, the integration maybe with other systems or the integration of other kinds of data, is that something that's also important when it comes to invest in an AOI system?
I think there's no question that data interfaces to integrate into a digital factory, call it Industry 4.0, but I think we talked about that a long time, so we don't call it that anymore. Now it's digital factory or whatever it is. We probably have hundreds of different data interfaces, because in the past every customer has its own strategy, even own software, and then there are maybe 15, 20 standard software packages out there that you need to supply the data to. So I'm very happy that we finally have a standard, an IPC standard for a data interface, the Connected Factory Exchange. That's quite an achievement. In parallel, unfortunately, even more, Jara's something that is that's pretty much the same standardized by SEMI, but still, that's two. And it's open standard, so we all need to and want to apply to it, because at the end, we all offer data analysis, some kind of process experts, you have a name for it, we have a name for it, SPI data, pre-reflow, post-reflow data, X-ray data, everything can go into that database, and you learn a lot about your process, or the customer learns it, and can use it. And we even adjust some, and I talk about thresholds again, some quality thresholds post-reflow based on SPI data. Because there are certain instances where you have maybe a higher but acceptable volume of solder paste on a certain pad, which is more likely to create a solder ball or anything else in that area later on in the process. So we tell the AOI system, that was the case, and we adjust sensitivity or tolerances according to that. So there's a lot of going on. Is that smart manufacturing? Yeah, it's just using the data finally, and I think we are now in an era where we have the capacity to store the data, to analyze the data, and to provide analysis back to the line.
Yeah. I mean, we can still discuss about the definition of smart manufacturing, but it comes to a point that everything's going to be more connected and that you have more data that you can use. So that's, yeah.
These days to connect is easy.
Yeah.
The question is, what is the value of the data?
Yeah.
And we are, I think, coming back to this, to have the data which are consolidated, which are structured, and which are validated somehow. So because the other devices which are connected in a smart factory or other systems as a schedulers and MES systems and whichever other systems even on the line, they will make decisions or corrections based on the data we provide. So from our point of view, the validity of the data is one of the very key factors, which sometimes is a little bit forgotten. We are connected and that's it. No. The validation is very important.
Yeah.
I would say in the meantime, we already realized the communication. We talk about the CFX and the Hermes. That's machine communication, but that's just status and a little bit more. I think we reached a level in the printer world with the SPI to communicate bidirectional actively to optimize the process. This is done within the SPI world and the printer world. Out of this, optimization of the setup, finding obstacles, checking the printer quality, if something damaged on the plate or anything is influencing the quality, and also tuning the setup, upgrading the parameter of the printer because the paste is getting older, it's not proper in the fridge, all these kinds of small things. This is an active communication, it's already available. The same in the pick and place. You realize by analyzing the deviations, we are communicating to the pick and place machine, advising, stop the nozzle, change it, calibrate the head, do this kind of things. So this communication has already placed in. We have to distinguish between the machine-machine communication to optimize this part of the process step, and of course to the MES. But if we deliver our data to the next level of system, we are just overloading. They are not designed for this 10,000, 20,000 measurement within seconds. So I think the communication is executed already. We prove it. And this is the benefit, because then it becomes smart, helping the operator, not only the operator, the responsible guys in the line to make the right decision. Okay. And focus not on the defect, on the deviation. The deviation is, from my opinion, the key for the future to avoid, not a defect, to avoid the risk of a defect. This is much more important. Okay. It's very precise. Avoid the defect is nice. Even the risk to go in that trend, that's our job to do.
Okay. So maybe we got now a question from you. Is there something that you would like to ask the experts here on stage? Okay, another thing that I would like to talk about is the limitations of 3D technologies. Are there any cases or applications where where there are limits to this technology, and which kind of technologies could expand the possibilities of the system? Which technologies would you need as an addition?
I'd like to comment about the limitations in terms of, there's two categories that I consider here. One is a hardware-based limitations. The other one would be in the case of software. So two different categories. In the hardware category, I think some of the limitations that we see currently in the market is challenges to the technologies in terms of depth of view, and components, very tall components, also very highly specular components, reflective components. Those are still presenting challenges to the current technologies in the market. In terms of software, again, the implementation of automatic programming capabilities, use of AI, and in some cases deep learning technologies can be adapted, and that's really where the biggest advancements I think are going to come in AOI in the future, is on the software side, to automate the processes and put intelligence into the software to do the majority of the programming tasks, accomplish those automatically.
Okay. Anyone wants to add something?
Yeah, limitations. I'm thinking.
Or are there no limitations?
No, there are, but it's I think we've come very far in 3D. So today's boards really have. I mean, as Harald says, design for testability is always a topic. I mean, you can design things together that are either not visible or can't be inspected right. But that's not a general problem of any 3D measurements. So I think a well-designed board doesn't have too many challenges. But of course, yeah, a lot of reflectivity is one thing. But I wouldn't say that's a general challenge. I don't know.
I think the limitation in 3D, we have to distinguish what we can see and things which are definitely under the component, which is not visible in any way. And then we have the X-ray technology to go in. Yeah. That's clear. That's not our core competence. So very clear that's a limitation in 3D. I still believe the right hardware will eliminate very often the shadowing. We have to optimize. We have to optimize continuously the shiny surfaces. Yes, we got it a long time ago. We could not cope with it. Now we develop things to cope with because it's getting into our daily business. It starts with a sample, can you do it? And then you say, Few years later, a few days later, a few weeks later, you have a bunch of applications because there's suddenly a trend. And coming to this trend, you have to provide a solution. Otherwise, you are facing the limitations. And if somebody has the solution, the customer has to move to the solution because he needs to solve it.
Okay, just wait a second for...
You should invite her.
Yeah, right. Okay, so... Well,
visit our Accelerating Talents area in Hall B2, stand 407, around the topic of promoting young talents and startups.
So maybe that's the sign for us, because time is running out. I would like to ask a last question. We will look in the near-term future, and let's imagine we will meet here again in Productronica, let's say 2023, in 4 years. What can we expect from the technology side? What can we see with new features and so on? That's then realistic in this time. Who would like to begin?
I think you'll see most of the significant advancements on the software side in terms of automatic programming. That's a big hurdle that we currently are facing in the industry. Every customer asks for it, and every company that's in our industry is working on it. And so I think that's the biggest improvements we're going to see next time.
Okay.
I think faster, more data, lower cost, pretty much.
Okay, those are really...
I guess, I don't know, but I guess From the inspection point of view, we see now that more and more components are starting to get a hidden joints. It's 60-70% of the total joint number on the complex PCB. So I think we will talk more about the X-ray in next, let's say, 5 years. That will become to be a standard in a production line. And maybe the 3D AOI will be still important, but I think the main technologies what we see might be SPI and X-ray combination, and to have a simpler AOI technology to check whatever is not visible by the X-ray. But I think that might be one of the directions. So maybe we will meet here at 3D AXI Arena.
Okay.
I don't know.
Yeah, we will see. We will see.
Do you advise me to take care of an X-ray machine now?
Oh, why not? Why
It's
not?
no problem.
Why not? Why not?
Maybe not.
It would be nice to have more people.
You ask what yeah, maybe coming back, what we will see. I think we have to see what we don't see today. We will see transparent material. We see small materials. Glass will be the future, high reflecting. And I don't think we should talk about what we should measure there. We should be able to do it. If you look to the next generation of components which are available on the market, you know how we will discuss. It will be things we will not see without tools.
Okay. And we will have this situation where we could just press one button. That's what you mentioned.
I will be retired at that time. I don't care.
Okay.
No, honestly, there will be a milestone forward. We don't know where we go, but definitely there will be a chance to help the customer. And we see labor cost is a topic, and we have to make sure that labor cost will not kill our business.
Okay.
Because you can find the system, but you cannot afford the engineer to program it. That will be worse.
Okay. Well, we all recorded this, so we can, in 4 years, we can just watch the video again and then see what came true. So we will see.
I'm looking forward to it. Thank you.
Yeah. Okay, so thank you very much for this great discussion. There were a lot of topics that we talked about. We could go on for a few hours, but as I said, the time's running out. So thank you very much, and
Thank you.
you.
Thank you too.
And wish you a nice forum. Thank you.